Welcome all of you in this online session. My name is Dr. Vishal Patil. I am working as an associate professor in Department of Mechanical Engineering, Sharan Institute of Technology, College of Engineering, Yesro. The name of the subject is thermodynamics. In today's session, we will study the fundamental part related with the properties of pure substance. It is under of unit number 6 of ideal gas. Then first part of this online lecture is pure substance. A pure substance may be defined as a substance which chemically homogeneous and has a fixed chemical composition. In general, any substance that appears with invariable chemical composition in either phase or combination of phases may be treated as pure substance. Water, nitrogen, helium, carbon dioxide are the pure substances. A system composed of liquid and vapor phases of water is pure substance because in either state the system will always chemically homogeneous without any change in its chemical composition. A mixture may also be pure substance, for example, dry air, mainly a mixture of oxygen and nitrogen. In gaseous phase, it may be heated, cooled, compressed, or expanded with no change in chemical composition. However, if it is liquefied, it is no longer a pure substance because the liquid air will contain higher fraction of nitrogen than its original mixture in the gaseous phase. Similarly, if air contains moisture and evaporated on the heating or cooled by condensation, its chemical composition will change. It will be no longer a pure substance. A mixture of carbon monoxide and oxygen is a pure substance as long as they do not react with form CO2. Then important point is the phases of pure substance. A phase is the homogeneous part of the system that physically restricts. There are three phases of substances. First one is solid, second one is liquid, and third one is gaseous. A substance may have several phases within the physical phase. Each phase has different molecular structure. For example, carbon may exist as graphite or diamond in a solid phase. Pure sulfur and iron each has three solid phases. Helium has two liquid phases. A substance in each phase has defined molecular structure, different form of and other phase. It will be helpful to have some understanding of the molecular arrangement involved in each phase. In a solid phase, the molecules are arranged in three-dimensional lattice, which is repeated throughout its volume. The attraction force of the molecule on each other are very strong, thus keep this molecule in fixed position within the solid. The molecules in solid phase cannot move relative to each other. They can only oscillate about its equilibrium position. The velocity of the molecules during each oscillation depends upon the temperature. When the solid is subjected to very high temperature, the velocity of molecules may reach a critical point where the intermolecular force becomes partially weak and the group of molecules break away. It is the beginning of the melting process. In a liquid phase, the molecule spacing is similar to solid phase with relatively weaker molecular force of attraction. In liquid phase, the molecules do not conform a fixed position relative to each other. Therefore, a group of molecules can float easily. The distances between the molecules in the liquid phases are slightly greater than a distance between molecules in solid phases for the same substance. The water being the only substantial case which expands on freezing and its molecule spacing becomes slightly greater in a solid phase than the liquid phase. Then in gaseous phase, the molecules are far apart from each other without any molecular pattern and force of attraction. The molecules of a gas are in continuous motion, colliding with each other and rebonding to move a new direction. The molecules in a gaseous phase possesses a considerable higher energy than they do in solid and liquid phases. Therefore, a gas releases a large amount of heat before it condenses or freezes. These are the descriptions related with the phases of molecules. The next important point for this online session is the phase change phenomena of a pure substance. This is the most important part of this thermodynamics. As per this figure, consider a cylinder fitted with a frictionless piston which may be loaded to any desired pressure. The cylinder contains 1 kg of ice at minus 10 degrees Celsius under 1 atmospheric pressure. At the state 1, as shown in this figure, the state of the heat addition is illustrated. For process A to B, when any amount of heat is added to ice, it gets warm and its temperature rises till it approaches 0.01 degrees Celsius, generally referred as 0 degrees Celsius, as shown a line AB in this figure. The process B to C. The following facts are observed during this process. First one is the ice begins to melt at 0 degrees Celsius and two phases mixed is formed. The temperature of the two phases mixture M1 and ice of the water does not change on the heat addition as shown in the figure by line BC. There is slight decrease in volume because the liquid water at 0 degrees Celsius is heavier than ice. At the point C, all ice melts to water without change in pressure 1 atmospheric and temperature 0 degrees Celsius. This phase transformation from solid to liquid is called melting or fusion of the ice. Then as per this figure, the process C to D, when heat is added to liquid water, the following things are observed. Then these things are: first, the temperature of water rises with heat supply and keeps on rising until it reaches boiling point of temperature at the point D. There is a decrease in specific volume of water when its temperature rises from 0 degrees Celsius to 4 degrees Celsius, and therefore the specific volume increases with temperature rises till it reaches a saturation temperature. The piston moves up slightly during this process as shown in this figure. The pressure in the cylinder remains constant at 1 bar. For process D to E, after water reaches saturation temperature, that is 100 degrees Celsius at 1 atmosphere, any addition of heat will causes the some liquid to vaporize at same temperature. This is again the phase change process from saturated water to saturated vapor. During this phase change process, the following facts are observed. First, there exists two phases mixture M2 of water and vapor called waste steam. The temperature of mixture remains constant until all water does not convert into vapor steam. The process of phase change takes place at constant temperature and pressure. The specific volume of vapor is considerably larger than the saturated water as shown in this figure. The state E, all the water has been vaporized and the state of the system is called dry and saturated steam. The phase change from liquid to vapor is called vaporization. The process E to F, once steam becomes dry then and saturated, it becomes as an ideal gas and its temperature and volume start increases with further supply of heat. This steam is called superheated steam. Means as per this figure, uh, there is clear description related with the phase change process from solid to liquid and liquid to gaseous or steam. The next important point related with these properties of pure substance is saturation pressure and saturation temperature. At normal atmospheric pressure, the boiling point of water and condensing of steam begins at 100 degrees Celsius. Similarly, at pressures, the boiling and condensation process will take place at higher temperature and at lower pressures. There will be takes place at lower temperature. The temperature at which the boiling and condensation process takes place is known as saturation temperature, denoted as T saturation. The corresponding pressure of the fluid is called as saturation pressure, denoted by P saturation. For a given pressure, there is fixed value of saturation temperature as shown in this figure, the variation of saturation temperature with pressure. X-axis indicates saturation temperature, y-axis indicates saturation pressure, and this curvature line shows the saturation curve which divides the liquid region and superheated region. This is the important point related with the properties of pure substance, means saturation temperature and saturation pressure. Saturation means the fulfillment of the criteria. The next important point is compressed liquid and saturated liquid. The liquid existing at temperature lower than saturation temperature is called compressed liquid or subcooled liquid. Because the pressure of the liquid is higher than its saturation pressure and this liquid is not about to vaporize. The temperature by which it is lower than saturation temperature is known as degree of subcooling. That is, degree of subcooling is equal to T saturation minus Ti, where Ti is the initial temperature of the fluid. The liquid at saturation temperature is given pressure about to vaporize is called saturated liquid. extract the latent heat transformation from the surrounding media and break away as vapor from liquid surface and escapes to surrounding atmosphere. Means evaporation process is conversion of liquid to vapor, but it takes place at any temperature. The process takes place at the higher upper layer of the liquid medium. Means in this free surface, means top surface extract the latent heat of phase transformation from surrounding media and break away as a vapor from the liquid surfaces. Means evaporation is nothing but conversion of liquid to vapor. Next one is boiling process. The boiling, it is a phenomena of the formation in the whole mass of liquid when heat is supplied. Means conversion of liquid to vapor with support of heat addition to the system. The boiling process takes place in related with all molecules of the liquid substance. In boiling process, there are all molecules are take participated in this process, and the boil just like the boiling point of the water is 100 degrees Celsius for the pure water. Next one is saturation temperature. The saturation is nothing but the fulfillment of the criteria. And saturation temperature means it is a fulfillment criteria related with the temperature. And it is denoted by T saturation. It is a temperature at which the pure substance starts to evaporate at a given pressure. Means at a given pressure, the starting phase of the evaporation is nothing but is saturation temperature. It means starting phase of evaporation with respect to temperature at a given pressure is known as the saturation temperature. Similarly, the saturation pressure. The saturation pressure means the fulfillment criteria related with the pressure, and it is denoted by P saturation. It is the pressure at which the pure substance start evaporate at a given temperature. Means at a given temperature, the liquid get evaporate from liquid to vapor. Means fulfillment related with the pressure condition. Next one is steam. Steam, it is a gaseous phase of the water. Means at 100 degrees Celsius, the liquid water is get converted into steam. Means conversion of liquid to vapor takes place. Means gaseous phase of water is nothing but the steam. The steams are mainly classified into two types: wet steam, dry steam, superheated steam, etc. Then saturated steam. The steam is about to condense. Means the condensation means conversion of vapor to liquid phase is nothing but the condensation. The saturated steam is nothing but the steam is about to condense. Then waste steam. It is a mixture of dry steam and water particle as moisture. The next point is dryness fraction. It is a measure of quantity of waste steam. Next, dry saturated steam, the saturated vapor which is free from moisture. Superheated steam, the steam existing at a higher temperature than saturation temperature. Degree of superheat means it is the temperature rise of the superheated steam above the saturation temperature. And last point is critical point, the focus of saturation curve where saturation liquid line and saturated vapor line meets. Then triple point, the triple point, the focus of PNT diagram where the three phases of water coexist. Then next point is sublimation line. Is the transformation of solid phase directly to the vapor is called sublimation. Then uh, for more details you can refer the reputed reference book Thermal Engineering by Professor M. M. Rathore, which is McGraw-Hill publication. Uh, thank you very much for watching this.